So we will continue on, and it was great to hear from everyone. And hopefully now you can put some voices and faces with the names. Um, so a huge part of this project is the community collaboration and public engagement piece, because ultimately what we're working towards is a network that is run and sustained by the community. So everything that we do right now is really a step towards that community monitoring network. So over the past year, we started to lay the groundwork by getting the community involved in selecting and establishing community monitoring pilot sites. We also raised awareness and increased knowledge about traffic-related air pollution and the project. So to do that and to accomplish some of these goals, you'll see photos of everything on here that we've done over the past year. So we held a focus group to narrow down the site selection and get input on the project and future sites, which I know many of you are involved in. We also worked with you all, the community organizations and local agencies, to establish sites and also figure out where's the best place to install these monitors at each site. And we also developed and installed the informational signage that provides access to the data via a QR code that takes you to the project website. We also did a variety of public engagement events, such as the Future Leaders in Planning summer program for youth, a lunch and learn session, and information booths. And I guess one of the things also that I want to note is when I say we, that's not just the TPO. That is literally every single person involved in this meeting right now and beyond. It's been a truly joint effort in getting us to this point and moving forward as well. So a few things that we have in mind for future community collaboration and public engagement is to increase engagement in the community and also increase the community's involvement in air quality monitoring and establishing additional sites. With this type of community involvement, it really works towards empowering the community to monitor their local air quality so they can then use those resources and that knowledge that they've learned to participate in decision making. We also recognize that this will take time and resources from the community. So we have included funding opportunities for community sites in the federal grant applications that we submitted over the past couple months. So the last goal that we've got on here is one of our longer term goals to establish a community coalition to monitor air quality. This is also an avenue for the community to contribute to decision making. And so to work towards those goals over the next year, some of the things that we're looking to do are to train community members to install the monitors, interpret and monitor the data from those monitors, and then also help conduct outreach. We're looking to increase the number of engagement and educational events that we do. We also want to identify key supporters and representatives from the community and the community sites, and just also establish more community sites and offer opportunities for individuals to host monitors, so that we can really establish a network, not just kind of a handful of monitoring sites. As I note on here, that is dependent upon funding and what we get as to whether or not we can actually purchase additional monitors. The last bullet on here is for the community sites to monitor and report on the status of their air quality. So this really is kind of an opportunity for you all and for community members to monitor the data and ask questions as well. And the training that we do for the interpretation and the monitoring will also help with that. So it's not just kind of jumping off into the deep end. So ideally, we're looking at every 6 months, we would do an update with the community sites as well. So some of the things that we'll be doing in the next couple of months are to do information booths at upcoming events, and that's really looking at individualized outreach events. Rather than doing a larger kind of all-encompassing event, we want to focus on tailoring the outreach to each of the communities where the monitors are located. We're also going to be training the community sites and the community members to interpret the data, and also training to install the monitors. This again is dependent upon the funding as to whether or not we can purchase additional monitors. And at this point, I want to take a minute to have a discussion with everyone to see what kind of outreach is most suitable for your site and for your community, kind of getting at the individualized outreach. So some of the questions on here are, do you have planned events where we can set up an information booth? And is there anyone who would be willing or interested to assist at the booth? The second question is, what types of public engagement do you want to see and be involved in? And the third question is, what types of events or information will be most beneficial for your community, but also for you as a site host? The last bullet, identify key supporters and representatives from your organizations. This is less of a discussion point and just something to keep kind of in the back of your mind. Because and if you do know of anyone right off the bat, then you can let me know and connect them with me. But if you think of someone later on, or if someone starts to show a really big interest in it, then you can also let me know as well. So we'll take about 5 minutes to have this discussion. If we don't get to, if there's still discussion left, I'll send out all of these questions to everyone, and so then you can provide feedback at that point as well.
Hi, this is Lena. I'm going to jump in because I'm so excited about this project and our children's involvement. We see this as a great opportunity for the various events that we have for the children, for parents, and of course we are a part of the larger, I'm sorry, I'm walking so you could hear my breathlessness.
That's okay.
We're a part of the larger Civic Association of Tampa Heights with several thousand residents within our boundaries. And we have ongoing activities and events at our community center. So we look for this opportunity to really be able to share with our community overall, and for us, most especially for our youth and children, to become knowledgeable and understand their environment and the place that they live. So we have ongoing events at our Civic Association Center, and so we look to incorporate opportunities there.
Yeah, absolutely. So I think because you guys have so many events, it might be easiest if I connect with you and Naya and see which ones it would fit best with.
I can speak for the library.
Okay, yeah, Sean.
I can speak for the library portion that outreach is managed through a central department, and I can give you that contact offline, and you could reach out to them. Obviously, we have more footprint than just Robert Saunders Library, but if you needed to target around that area, that's something that can be worked out as well.
Okay, that's wonderful. Thank you. Does anyone else have any other input? I'll send this out, so if you guys think of anything afterwards, then you can also send those to me. Oh, and I see a hand. Yeah, Eric.
Festivals that the forestry department normally attends is the Clean Air Fair, which fits right in.
Mm-hmm.
And I believe that was held downtown again this year, I think on Jackson Square, right by City Hall. And then there's also in April is the Eco Fest that was held at the Museum of Science and Industry this year.
Yeah,
So
I
those
think
are-
we were, oh, sorry.
No, that's it. That's all I got.
Okay, I think we actually had a booth there. It was a combination booth with the TPO and the Planning Commission, but we did have the actual purple monitor there, and we showed the map there. But so yeah, that's right on track. Okay. Don't see any other hands. So I think at this point, I will pass it along to Yang Hong to give another update to you guys. And Yang Hong, you should have access or the ability to share at this point. Is that correct? And you're on mute.
Yes. Okay, I share my song. Okay, I'll just give a presentation. Yeah, can you see it?
Yes.
Okay, good morning, everyone. To phrase the presentation of our project, I first want to start with the goals of our involvement in this project. These goals are to inform methods for the integration of low-cost monitoring data, including its uncertainties, into community and MPO decision-making processes, and also to determine ambient levels of traffic-related air pollution in a historically disadvantaged neighborhood near I-275 with predicted disproportionate exposure, and also to inform best practices for building government, university, community partnerships for sharing air quality monitoring data and expertise. To progress towards those goals, we've been working on several tasks. Here I'll present progress and findings on community monitoring selection and evaluation, as well as the current state of access to the community side data and its interpretation. And to identify and select air quality monitors that may be most appropriate for community deployment, we first performed extensive literature review and also did some pilot testing involving setting up candidate monitors in a controlled field. The major criteria we have been used to select monitors for pilot field deployment are shown in this table. First, we were interested in pollutants associated with traffic-related air pollution and have especially been focusing primarily on PM2.5 and NO2, with a secondary focus on VOCs. So NO2 is nitrogen dioxide. It's an EPA criteria pollutant that has a federal standard level and is often used as a surrogate for traffic-related pollutants. PM2.5 is another criteria pollutant that has many sources, but on-road vehicle combustion is important source and the levels tend to be elevated within a few hundred meters of roadways. It is also currently the pollutant most implicated in health effects. And there are many low-cost monitors that can measure PM2.5 and NO2. Finally, we are secondarily interested in other toxic organics that are associated with traffic, such as benzene. However, there are no integrated low-cost monitors that we have found for these specific chemicals. So we have focused on the larger class of compounds called volatile organic compounds, that is VOCs, and that include some toxic organics. Other criteria we used is the size. We hope the size is small and it's easy use logistics that can be easy for the community members. And it has a public shared website and fairly good data quality. This table provides a summary of the monitors that we have identified for potential community monitoring. This list includes monitors that focus on one pollutant type, like the purple air, air bin, livable city, Kerosene clarity, and monitors that are designed to measure multiple pollutants, like the clarity, Atmo tube, and flow tube. And the list also includes some monitors that are intended for stationary employment and some that are primarily variable mobile monitors, and some that can be used in both. For the standalone PMO monitors, like you see in here, Purple Air and Air Bin, the price is about $250. They also have the highest reported data quality compared with other monitors. The cost of the standalone NO2 monitors you see here is around $1,000, but the reported data quality is poorer than the PMO monitors. The one stationary multi-pollutant monitor is the Clarity, this one, and it measures both PM1, 2.5, 10, and NO2 with reported good data quality. It is the easiest to use monitor that we have tested thus far. Because it has incorporated solar panel and Wi-Fi, simplifying the installations in the community locations. For the variable monitors like the Atmo tube and flow tube, the price is low and they are easy to set up and use with co-located cell phone. But testing has indicated a difficulty in their use for stationary monitoring. They may be appropriate for supplemental citizen-based mobile or personal monitoring. Okay, I'm sorry. The method we used to test the monitors' performance are based on EPA's guidelines for PM2.5. We hope to understand how well these novel small monitors perform. There are three important perform concepts. They are completeness, accuracy, and precision. So completeness means how consistently the monitors measure usable values. And the accuracy means how close the measured values to the true value. And the precision indicates how refined or resolved is the measurement. To determine the accuracy, we collocated each monitor with a regulatory monitor for the same pollutant at the Monroe site. We compared the 24-hour average values for PM2.5 and 1-hour average values for NO2. These are averaging times that correspond to the national health-based standard levels. The important metrics that help to understand the monitor's accuracy are bias, linearity, and error. We were also interested in an accuracy drift over time. To determine the precision, thus far we collocated 3 Purple Air at the EPC site and performed a 2-month campaign for the with 3 air bins at the field's home site. Standard deviation and the coefficient variation and parameters were used to measure the precision. This slide gives the overall raw performance of the PM monitors for which we have data thus far. And the blue point in the first graph indicated here indicated the reference 24-hour average PM2.5 measurements to which all the monitors' values are compared. From an accuracy perspective, we can see that these monitors generally follow the variation in values from the regulatory monitor, but consistently measure a larger range of values. And it's over-predicting the heights and under-predicting the lows. This can also be seen from the 4 graphs on the right side. The horizontal axis represents the reference concentration that we expected to be the best measure of the true value, while the vertical axis shows the monitor's measurements. When these blue points fall along the gray diagonal line from the bottom left color to the top right color, this indicates it indicates this monitor's value are the same as the reference values. So when they fall on the straight red line shown here, you can see here, it indicates the values is more linearly correlated to the reference values. Both suggest the monitor performed better. So we can see that raw data from the Purple Air, Clarity, and Atmo 2 had have the similar accuracy for the period investigated, with weak performance. Overall, R squares about 0.4. The left bottom graph here shows the precision test result for the Purple Air expected, except for the coefficient of variation of the Purple Air is a little higher than EPA's criteria. Other metrics match the standard well. So in the previous slide, we saw that accuracy of the raw data from the monitor over a 4-month period was low. Calibration is used to improve the accuracy of the monitoring data. This is necessary because the technology used to measure pollution in these monitors is different from the regulatory monitor, though all monitors typically require calibration. Additionally, meteorological conditions like the relative humidity, temperature, and other factors can influence the raw measured values. Calibration of monitoring data involves the statistical adjustment of the measured values to better match the reference monitor monitor's value. Here we focus on the Purple Air and Clarity monitors. The calibration equation recommended by the EPA for Purple Air data is showing on this slide. You can see here. And the Clarity data showing here are calibrated by the manufacturer. Here's the model. And look at the scatter plot here and the table measured here. And we can see that the calibration improves the accuracy of the data for both monitors. For Purple Air, the EPA calibration method improves the bias and the error substantially, but it only improves the linear relationship with the regulatory monitor a little bit. For Clarity, the performance improves substantially for all measurements. Although the performance of the calibrated Clarity data looks a little better than the Purple Air here, the R squares here you can see is 0.8 versus 0.59. We note that the time period of the comparison is different. We still need to compare those for a longer time period to conclude regarding their comparative performance. However, so far, the calibrated data quality look moderate to good. Another important thing is to look at how performance changes over time. Performance is known to degrade over time due to many factors. For example, dust can collect in the monitor, affecting particle counts. To measure this and drift, we compare results from the first 2 months of the data collection to the last 2 months. These two graphs shows the first 2 months results, and these two graphs shows the results of the last 2 months results. For the Purple Air data, for which we have an 8 months record, it is obvious to note that the blue points are further from the red line for the more recent data. More than like 80% of the Purple Air data has a linear relationship with the regulatory monitor at the first, and this value fall to 40 here and here. Yeah. 40% in the last 2 months. This degradation of the time indicated that a regulatory maintenance plan, such as involving replacement or cleaning of the devices, will be needed. For the Clarity data, we don't see much degradation in the quality, but we only have 4 months data, and we'll need to look at this again after more time has passed. Now let's look at the second pollutant we are interested in, NO2. NO2 is much harder to measure and has more interferences than PM. It can be affected by the temperature, relative humidity, and other pollutants like ozone. The monitors that measure NO2 that we have tested so far are Clarity, Flow2, and CareSense. These results need further analysis to ensure they are representative, but all preliminary results show weak to no correlation with the regulatory monitor. The Clarity performs better, but the calibrated data still show no performance values. Publications in the scholarly literature suggest that using ozone might be a good approach to calibration NO2 monitor and improving its performance. Therefore, we think there's a need to try the next step. In addition to monitor testing and evaluation, we've also been assisting the MPO with community monitoring site selection and community site installations and educational community outreach. These installations have focused on the purple air and the Clarity monitors because these monitors are the easiest to use in a community field setting and have reasonable potential performance. One of the objectives of this work is to build community capacity for understanding this data, so community data access is instrumental. Hence, the MPO's project website provides links to the site data as shown here. Access to the Purple Air community site data is provided by through the Purple Air map website. On this website, you can see here, anyone can explore air quality levels over time at each of the sites and download the data for further analysis. Clarity data can be accessed through the Clarity map website with similar capabilities. We will be developing materials and educational activities to teach community members more about interpreting this data, but please feel free to reach out to me after the meeting if you have questions now or what to get a head start. One very helpful tool for understanding air quality data from a health perspective is the EPA AQI Air Quality Index website, whose link is also provided here. And to get the thinking started, let's take a first look at the community site data collected so far. This slide shows 24-hour average PM2.5 concentration trends over time at the 4 sites with purple air monitors. In each graph, the blue dots represent the concentration measured directly by the monitors, while the red dots represent the calibrated concentration using an EPA recommended model. Some things to note to help understand the data are, firstly, the background level of PM2.5, meaning levels in a clean atmosphere are typically a few, like less than 5 microgram per meter cube. And 2 is the daily and national ambient air quality standard level designed to be generally protective of health is 35 microgram per meter cube. The third is annual national ambient air quality standard levels designed to be protective of health for long-term exposures. That is 12 microgram per meter cube. So remember, like 5, 12, and 35. We can see from this data that all 24-hour values are all below the primary daily standards of 35 microgram per meter cube, indicating that there's no regulatory concern. However, there's evidence in the literature that there are detrimental health effects even at values below the national ambient air quality standard for some populations. Here we see many days that the average concentration exceeds to typically background levels, and some spikes that reach about like 20 microgram per meter cube, like this like this. We will all want to investigate what conditions, including times of day, week, season, and other conditions, including traffic, correspond to these spikes, as well as whether these spikes occur more frequently at some sites than others, and whether the EPC data represents the community data. So one analysis that can help understand how concentrations vary over time is to look at average concentration over the day. This slide shows this diurnal circle for PM2.5 at each purple area installing site in the community. The blue line, you can see here, is like this blue line in each graph indicates the average value throughout the day. The highest value appears to typically occurs at about 7 a.m. and which may be due to morning rush hour traffic. We also see pinks in the late afternoon at Temple Heights Junior Civic Association. This may be due to evening rush hour. The maximum value in each hour in the community are larger than EPC's maximum value. In the Seminole Elementary School and Newmont Zion, the largest pinks were measured. We were looking into possible reasons for these pinks. We can also look at the average value for each day of the week through weekly circle plots at each site. This shows that the highest PM2.5 concentrations during the week are generally measured on Thursday. And levels over the weekend are also lower on average compared to the weekdays. So in conclusion, there are several findings we'd like to highlight, like the community air quality doesn't appear to exceed standard levels for the time period studied, but more analysis of variation and comparisons are needed. And truly low cost and easy to use monitors that provide public data, but still remain limits. And the initial and ongoing calibration of network will need to be designed. And results show promise for widespread community monitoring and data sharing, but sustainable network will take further development. So for the next step, we will keep doing on continued monitoring, testing, and evaluation, especially for the longer time period, and develop data calibration methods, especially for the NO2 monitors, and also do some additional community monitoring installations, community learning on data interpretation. We will also develop ongoing engagement materials and methods and instruments for studying engagement and empowerment. Okay, thanks for your attention. So do you have any questions or suggestions?
I don't really have any questions, but I just wanted to say thank you so much for like that report, the comprehensive report, and just kind of explaining everything for us, you know, so that we can understand. So I just wanted to say thank you for that.
I'll check the chat and see if there's anything in there. Okay, I don't see anything in the chat. If no one else has any questions, then Younghong, we've got 10 minutes left, so do you want to do just kind of a quick demo of the purple air map?
Yeah, let me share.
And if anyone does come up with any questions, you can put them in the chat and I'll monitor that as well. Also, while Yonghong is pulling that up, I know that I missed someone when we were doing introductions. So Cody, I don't mean to call you out, but do you want to do an introduction for yourself? I'm so sorry that I missed you.
No, that's okay. That's okay. Can you see me?
Mm-hmm. Yep.
Hi, my name is Cody Winter. I work alongside Michelle Jenkins and Jason Waters at EPC. I work directly in the air analysis section, and I assist Michelle in sustainability matters, as well as handle in-house enforcement for various air division cases. So,
Thank you.
Okay, can you see the map? Purple
Yeah,
air.
we can.
Okay, great. So when you Google purple air map, you can get in this purple area time air quality map. And then you can zoom into the areas that you are interested in, and you can see circles on the map that show the purple air monitors at different locations. For any site, you can see the data from any monitor. There are many data layers to view on the purple air map. I will talk about two important data layers that I think are very important to help us to understand the data on this map. So let's start with this 5 particle map. If you click this here, and you can see this is data layer, and if you just click this arrow here, and you will see this. So let's start. There are many like data layers you can see. Let's start with this row PM2.5. If you select that, this data just show you this row PM2.5 concentration, and you can select the average time, 1 hour, real time, 10 minutes, 30 minutes. You can select. So the real time means every 2 minutes data in here, and you can select the like 1 day. You change the number has been changed.
And then that's the average. Then the value becomes the average over a day, or the average over 30 minutes if you choose that. So it's saying which values is what average is it showing you?
Yeah, that's right. So this is the average period list. So although these pollutant concentration values are informative to like air quality specialists, but they can be confusing to everyone else to understand. So to understand what this means, another important data layers that can help, that is the air quality index. If we just select this one, and you can just select this here, US EPA PM2.5 air quality index. And you can see the data is changed. So this means this air quality index is a measure used by the US Environmental Protection Agency to communicate air quality levels using a health perspective. So using an equation that accounts for the levels of a particulate pollutants that correspond to the health effects. So each sites for PM2.5 concentration values that can convert to air quality index values. So if you click to the this,
Yonghong, do you want to explain the colors and go down to the bottom left corner and talk about the air quality index colors?
Yeah, I want to show us the air quality index values. Let me just. Okay. So there is the air quality index basics that tells us these different colors mean to us. So when the color is gray, that means the AQI, the air quality index value is between 0 to 5. The air quality is satisfactory, and air pollution promotes little or low risk. When the color becomes yellow and orange, when it becomes orange, it means unhealthy for sensitive groups. The AQI values is between 101 to 150. The members of sensitive groups may experience health effects, and the general public is less likely to be affected. So when it becomes red, it means health, and purple means very unhealth, and maroon means hazardous. So based on this color, we can go back to this purple air, and there's color bar here. It shows that in different color. This is like correspond to the EPA's air quality index values. So when, let's see, when the color is gray, it means the value is in the circle is between 0 to 50. It also means the air quality is good, just as I said before, and there's a little risk from this exposure. So when the color becomes yellow, there's a little bit becomes yellow, and it means the value is in index is between 51 to 100. It also means the air quality is moderate. The air quality may be risk for some unusual sensitive population. So when the color becomes orange, like in this area, and it means the pollutant level generally access to the U.S. National Ambient Air Quality Standard, that is allowed level, and the air is unhealthy for sensitive population. As the red color becomes darker, it means more people will be affected, and they may experience more serious health effects. So if we click the circle, click the circle here, and you can see a pumped panel appears. The panel shows some basic information on purple air monitor at a specific site, along with some information on current pollutant levels at the site. Now the large number here, the 16, is showing the current, let's see, a US EPA air quality, PM2.5 air quality index value. The value is the center, is the value center. Give the current average value for different average in time. The real-time AQI value is 15. So the average value, like the 10 minutes is the lighting, and the 30 minutes is lighting. And so the 1 day here, the 16 means the 24 hours, the 1 day value is showing here. Like it's also the same in here. It also shows other information like the signal and the site. So this sensor shows the seminar elementary school site and their quality air quality index values. So in addition to view the real-time data on the map, we can also see the trend in the pollutant level over time at each site. Like you can see here, this is the trend shows here. So the map shows us the variation in concentration and also the AQI over the 1 day. The whole time period is 2 weeks, and each dot in here is the 1 day average value. So if you want to view all the data from these specific monitors, for example, you want to look at the trend over a long period of time, because there's only show 2 weeks, or compare the trend with from multiple monitors, you can click the arrow here, and it will lead you to the data download page. You can select the time period that you want to download and select the average time here. You can select 10 minutes, 30 minutes or 1 day, and download the data. So this is a brief general introduction about this Purple Air.
Thank you, Younghung. That was great. Does anyone have any questions on the map? I know we're right at 11:01, so I think we nailed it on timing. But if anyone has any questions, then we can also stick around and answer those. Yes, Eric.
I was just wondering in looking at that chart, there was that peak that went up into the yellow for 1 day specifically. Is that the kind of information that we're looking for to see if there's things that coincide with traffic patterns? Because we did choose along the main highways and stuff like that. Is that like the big one?
Yeah, yeah. So kind of looking at where those, this is Amy Stewart. Looking at when those peaks happen, if they routinely happen at certain periods of time, if they, so kind of we haven't looked at that specific peak, but that is the general idea, is kind of looking at when do the levels peak and what does that correspond with, either regarding meteorology, traffic, other things as well. Like for instance, at Seminole Elementary School, there's a time period when a lot of people are dropping off their kids and the buses are coming by, and we might expect there to be a peak during that time. And we'll see if that happens.
Yeah, sorry, math geek. I just love that stuff.
Yeah.
So it's one of those. I see a peak like that. I'm like, ooh, there's something there. So,
yeah. And
thank
actually
you.
at Seminole, they want the students to actually do it as part of their class. Well, they'll take a look at the data and look at those peaks and think about what they might mean. So that's
Yes,
kind of
now's the
exciting.
time to be outside.
Yeah.
Thank you.
All right, do we have any other questions? Not seeing any. So thank you everyone so much for your
Thanks.
time. Oh yeah, and Allison, if you want to jump in.
Oh yeah, just before we all go, I did want to thank everyone again for participating in this project. Everyone's been more than helpful, and really it's just super collaborative and friendly. And I think it's a really good example of how we can all work together. I wanted to, Lizzie asked you earlier what outreach opportunities you might prefer, or what you think the best way to reach we have different communities. We're looking at schools, the community in general, different aspects. And I think sometimes there's meeting fatigue. So what we're hoping in the next year, or maybe a year or two in the future, is when you see an event that you think we can piggyback onto, that might be a good place to do outreach for this event, and along with another event, starting school events, let us know, and maybe we can talk about how we can coordinate that. I think that might be maybe more effective than just holding standalone meetings. So thank you.
Thank you, Allison. And thank you everyone so much for your time today. And it was great to talk with everyone.
So much.
Thank you.
Thank you.
Thanks,
Have a good weekend.
everybody.
Bye, everyone.
I know.
Bye.
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 Thank you.
Bye.
Great
Bye.
meeting.
Thanks.
Fine.